Hey boys and girls, Mr. D here. In this video, we're going to be taking a look at a factor a polynomial by using its greatest common factors. Okay, so we'll take a look at a few examples, and then we'll do some more practice when you get back in class. Okay, so take a look at example 1 here. It'll give us this equation here, factor the polynomial, and just for the time being, so we don't get distracted, let's slide this over here. Okay, so factor the polynomial. Here's what we got. Okay, let's take a second. Let's copy down our steps here. It's a little bit long, so press pause in the video and copy down these steps, and we'll go through it and we'll explain them all. So press pause now and copy it down. Okay, wonderful. So hopefully you've got it all down. Let's take a look at the first part. Factor each term by listing the prime factors of each term. Now, when you see prime factor, for the rest of your life, when you hear prime factor, I want you to think about factor trees. And we've talked about that before earlier in the year, but I'm sure most of us have probably forgotten it. But factor trees, the stuff we learned way back in elementary school, but we almost never used. But when you hear factor tree, when we hear prime factor, you got to think factor tree. Okay, so we're going to factor each term by finding its prime factors. Okay, so let's take a look at this. Here's what we're going to do here. So 8x cubed. Again, we want to make a factor tree of 8x cubed. So our factor tree of 8 is 4 times 2. 4 is not prime, so we break it down again to be 2 and 2. 2 is prime, 2 is prime, 2 is prime, so we're all good there. So the way we would list out our factors here would be 2 times 2 times 2. Then our x's we have times x times x times x. Okay? Terrific. Let's take a look at 12x squared. And so let's do our factor tree with 12. And again, you can multiply, obviously, hey, we could do 6 times 2, we could do 4 times 3. It does not matter which one we start with. It'll all end up in the same place, as long as we do it correctly. I'll do 4 times 3. Okay, 4 breaks down to 2 and 2. 3 is a prime number already, so we got 2, 2, and 3. So there's our prime factorization of 12. So let's write out those terms. It would be 2, 2, 3, and we got x and x. X and x. Terrific. Let's take a look at our 10. Let's factor out our 10x. So 10 as a factor tree would be 5 and 2. They both happen to be prime, so let's write up our prime factorization. It would be 5, 2, and then times x. So what we want to do now is, if you take a look here, we want to find the greatest common factor, the GCF, of each term. So in other words, what do all these terms have in common? What's the minimal that they all possess, that they all have? So if we look here, at the most basic, they have an x, right? Every one of these has an x. Some have more than an x, but we got to find something that they all have. Okay, so the fact that this one has 3 doesn't do us any good because this one only has 1. So we got to go with just the 1x. Same thing with our 2's here. This one has 3 2's, but the 10 only has 1 2. So we just got to keep it at the minimal that they all possess. So in that case, we would then say our greatest common factor, our GCF, is 2x. Okay? So what we'll do then is we pull that greatest common factor out of each term. So what does that mean? It means this. So take a look here. You like how I did that little magic of technology. It just happens to appear. But if we pull a 2x out of each term, so take this 8x cubed. Here's how I factored it out. Here's my greatest common factor, 2x. So notice I put a 2x in front of each of the 3 terms. And what remains is actually the part that we didn't use. So look, 2 times 2 is 4. And here's my x squared. Okay, and if you look, if I multiply these 2 terms together, 2 times 4 is 8. X times x squared would be x cubed. And I'd end up with the same term I originally had. Again, I pull out my greatest common factor out of that second term, 2x. Right? And look what would happen to remain here. 2 times 3 is 6. X. And you can always test it. 2x times 6x is 12x squared. 2x times 5 will give me 10x. Okay, so we pull out, we figure out through prime factorization our greatest common factors, but they all have in common. And we pull that term out of each term. And now, as I can hear some of you screaming through my headset right now that you're confused and you have no idea what's going on, it's really not that complicated, guys. You can handle it. We're going to make you lose your mind even a step further. Since each of these terms have this 2x in common, we can bring it out to the front, okay, and put parentheses around what remains. And if you look, do some distributive property in your head, and you can see we really have not changed this original problem at all. If you distribute 2x times 4x squared, well, you should know that that would be 8x cubed, the same term we have here. 2x times 6x, well, that would just be 12x squared, the same term we have here. And 2x times 5, that's a little easier for all of you to see. 2x times 5 is 10x. So we have not changed this polynomial at all from that first step to here. We have just called factoring it. Okay, so when we factor something, we want to look for the greatest common factor, and we want to pull that out of every term out to the front. That's essentially what we're doing. Okay, so let's take a look at one more example. So, in this second example, again, here's your same steps. You do not have to recopy these as long as you've copied them nice and clearly in your notebook. I just have them here in this slide so you can refer back to them as we're working through it. So again, we'll do it all the same way. Factor each term by listing the prime factors. Again, when you hear prime factors, what do you think? Shout it out nice and loud so mom and dad can hear you and think you're actually learning something even though you're so confused right now. That's right, it is a prime factors means factor tree. Awesome, and I know you're not all confused. I know you're not, because you guys are super smart. So, here we go. Let's factor each term using prime factorization, okay? So 6n to the 4th. Here, I'll slide it all down so we can see all the terms here, okay? So 6n to the 4th. Let's factor our 6. Using a factor tree, it's 2, and it's 3. Okay, so that gives us 2, 3, and then we got our n's. N, 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 and N. Got 4 of them there, okay? So that's factored using prime factorization. Factor our 9. 3. 3 is prime. So we're set there. You have 3 times 3, and then you have 3 n's. N, N, whoops, and N. Those are n's, trust me. I promise you. Alright, and then let's take a look here at number 12. Again, 2 ways we could do it. Last time we did 4 and 3. We'll do it 6 and 2 this time, so that way you guys can see the difference and how it works itself out to be the same. Okay, and then 3, 2, 3, 2, it's there. You know it's there. Play along with me. Use that imagination. Alright, so we got 3 times 2, because that's from the 6, the 3 and the 2 that you can't really quite see there. So, yeah, it's there. Trust me. 3, 2, and then this 2 here. And we have 2 n's. N, N. Beautiful. So, if you look here, our common factors between the terms, again, usually start from the lowest degree, see what you have in common here. We have 2 n's. Well, all these have a minimal of 2 n's. So that's great. We can use 2 n's from them. Let's look at the constants here. I got 2, 2, and 3. Well, this term here doesn't have any 2's, so that's going to eliminate using 2's here. But we do have a 3 in common. And here we have a 2 and a 3. We've already said we cannot use the 2's, but hey, we can pick up this 3. So, our greatest common factor for this polynomial, GCF, that's a G. My writing here is struggling. GCF is 3n squared. So again, what we're then going to do is we'll pull out the greatest common factor out of each term. So if we do that, look what you got here. Pull out that greatest common factor out of each term. And again, you can always check 2 ways. By listing it out like this, I can see what's left easily. I have 2n squared. Bam. Here's what I used to pull out. Here's what I did not use. Again, here's what I used, 3n squared. Well, what I didn't use was a 3n. Bam, there it goes right there. And if I multiply through, it always comes back. 3 times 3 is 9. N squared times n is n cubed. Okay? What I used to pull out was my 3n squared. What's left? Well, 2 times 2 is 4. So again, if you look, each of these terms has this 3n squared in common. So we can pull it way out to the front. And we just leave the sum or difference of whatever terms are remaining. Again, do your distributive property and you end up with the same equation as you started with. Right? 3n squared times 2n squared, well, it's going to be 6n to the fourth. 3n squared distributed to 3n, well, we already did that one. That's 9n cubed. 3n squared distributed to 4, well, 3 times 4 is 12. My n squared, so there it is. So that right there is our factorization of this polynomial. Okay, so hopefully that helps to clarify some things. We'll do some more practice with this in class, and then we'll be getting into some good old FOIL. All right? I'll see you guys in class. Hope this was helpful.